and we're going to look at matrices. Matrices are a pretty cool topic. There's a lot of different applications to matrices in the real world, and we're going to talk about a bunch of them in this chapter. Things like computer graphics, cryptography, cracking codes. There's a lot of really neat things that we can do with matrices. In fact, some of the stuff we did in the last chapter with solving systems, we're going to actually use matrices to solve systems a little bit later on. Before we get to all of that, I have to just introduce some key terms to you, show you exactly what a matrix is, and from there we'll do some operations with matrices, add, subtract, multiply. That's coming up later on, but for right now, 4-1 is going to just talk about an introduction to matrices. It's mostly vocabulary. That's why we're doing a little bit of a different format for the video this time. It's more of a narrated PowerPoint and not so much of a me writing all over my iPad like I've done in the past. So we'll see how this goes. Alright, so some of the goals in section 4.1, you don't have to write this down. This is just for your reference so you understand what it is we're actually going to be talking about in this PowerPoint. We're going to identify elements of a matrix. We're going to talk about these things called dimensions of a matrix, kind of like dimensions of a picture. A matrix has dimensions similar to that. We're going to talk about how we can find those. We're going to have a bunch of definitions, different types of matrices, some special types of matrices. And then finally, and this is more going to be some of the practice problems that you're going to look at, we're going to look at how we can convert some real-world data that we might collect into a matrix, because that might come in handy both to organize the data and also to do some manipulations with the data and some analysis with the data, all of which you'll do both at the end of this presentation and as well as in class tomorrow. Okay, so for starters, what are matrices? So a matrix is a rectangular array of variables or constants, or both, that are put in rows and columns enclosed by brackets. Okay? Each value in a matrix, you'll see there, the other bold word, is called an element. So what am I talking about? What does a matrix look like? Well, here's an example of a matrix. Okay? This is matrix A. Notice we're using a capital A to represent a matrix, unlike lowercase variables that we've used before to represent just a number. When we talk about matrices, we use uppercase letters. When we talk about specific elements of a matrix, there's some funky notation that I'm going to pop up on the screen. We use a lowercase version of whatever letter we used for the matrix. So in this case, we're going to use lowercase a. And then you see that 21 down there as like a subscript? It's not really 21, but rather 21. Where that comes from, and the fact that this A21 element is 0, is the fact that the element in the second row, that's where the first number comes from in that subscript, and the first column, there's the 1, is 0. So whenever you're writing specific elements of a matrix, or you're asked to find a specific element of a matrix, you look at the subscript. The first number tells you the row to look at. The second number tells you the column to look at. And you'll be asked shortly when we finish this PowerPoint to do some practice problems where I'll give you some matrices, or rather your book will give you some matrices, and you'll come up with different elements. So that's how you read that notation. Okay? Row first, column second. Now we got to talk about dimensions of a matrix. Just like you can measure pictures, just like you can measure things with dimensions, you know, it's a 4x6 frame or something like that. We can do the same thing with a matrix. The way we define dimension is we talk about the number of rows by the number of columns. So we say m by n for the dimension of a matrix, and that means m rows and n columns. So here's some examples. All right, there's a matrix A and a matrix M. So if we look at matrix A, it's got how many rows? 2. How many columns? 4. So we would call this a 2x4 matrix. If we look at M, that has 3 rows and 2 columns. So we will call that a 3x2 matrix. Okay? Just like we said row comes before column when we're looking at elements of matrices, Row also comes before column when you talk about dimensions of a matrix. Okay, m rows by n columns. You'll also be asked in this section, if I give you a matrix, not only to identify elements of a matrix, but also identify the dimensions of the matrix, and that's the key for that. Okay, the last little bit of vocabulary, there's some special matrices that your book mentions in section 4.1, and I want to bring them to your attention because we may use some of these special matrices in the future as we're talking about some different operations with matrices. The first type is a row matrix, and just like the name would suggest, it's a matrix that contains only one row, and there's an example of one. This would be a 1 by 2 matrix because it's one row of 2 columns. If there's a row matrix, well then you guess what the next thing would probably be. A column matrix. And a column matrix is made up of only one column, but it could have as many rows as you want. Here's an example of that. This would be a 4 by 1 matrix because there's 4 rows, but only one column going straight down. 1, -2, 4, 10. Okay. Third special type of matrix is a square matrix. That just means the matrix has equal dimensions, where the number of rows equals the number of columns. Here's 2 by 2. The best way I remember that it's a square matrix is if you think about it, if you drew a box around that matrix, it would form a square. We'd have 2 by 2, just like a 2-inch by 2-inch rectangle is a square for a geometry class. Same idea. Finally, the last special type of matrix is a zero matrix. And this is a matrix where all the elements are the number 0. So there's one. Its dimensions are 2 by 4, but it could have any dimensions. As long as all of the elements are 0, you have what we call a zero matrix. Okay? That's really all there is in section 4-1 that I want to show you on this video. I want you to try numbers 1 through 8, all of them, from page 188 in your textbook, basically asking you to do these same kinds of things. Pull out elements. Write the dimensions. Number 8 is going to ask you to write a matrix, given some data, and do some things to that matrix, add different columns, add different rows. Give it a try. We'll talk about all of those things, because that's going to lead into some of the stuff we're going to talk about both in class tomorrow and in future classes where we're going to do some analysis of matrices that use real-world data. Okay? So with that, have a great evening. I will see you tomorrow, and get ready to start talking about matrices.